Hello and good morning. We're in week 6, and today goes right here. So this is 9, 21, 21. Okay, so let's talk about slope here. Remember, your test is this weekend. So slope is going to be y minus y over x minus x. This becomes a plus, and this becomes a negative 7. And again, I like my negative at the top, so I'm going to leave it up here. There's your slope. Rise over run. Okay, so we did that. Find slope, find point slope. Well, point slope, you could use either point, but we're going to use the first one. So if it doesn't say, I want you to use the first one. Okay, so there's my y, there's my x, and there's my slope. Find perpendicular. So number 1, number 2, perpendicular, you got to flip this and change it. So what you're going to have is positive 7 over 11. And then this right here is going to be a plus because it's a double negative. So the only thing you change is the slope. Flip, change. Number 4 gets a little harder, and we might have to do fractions. So put a star by this. The easiest way to do this is to multiply everything by 11. Trust me on this. So you're dividing by 11, so multiply by 11. Now, the reason why you don't put 11 up in here is because this is times. So when you put the 11 right there, it covers all of this. Now watch what happens. So you get 11y minus 44, right? 4 times 11. Here the 11's cancel. Now distribute the 7. So you're going to get equals 7x plus 14. Draw a line. And what you want to do is solve this equation for y, which is slope-intercept form. So you're going to move this 44 over here. It becomes a plus 44. So you get 11y equals 7x. And that looks like 44, and now it's going to be 58. And then finally divide by 11. And here's your answer. If you follow this little trick that I showed you by clearing the denominator, it will be much easier. You'll avoid fractions. All right, let's move on. On a new sheet of paper, copy everything here. We're going on to chapter 3. In order to do chapter 3, you have to know some special lines here. And watch what I do here. All right, so this is your x-axis and this is your y. So what you do is you go up 2, because that's what that says. So y is 2, and I don't want you to put dots, I want you to put little slashes like this, because this line right here is going to look like that slash. See how it's sideways? And that's all you do. But you need to know that. These are special cases, and this is how I do it, and hopefully you do it the same. That way you remember it. This one right here is x. Here's x. So negative 1 and negative 2, it's going up. And there it is right there. So that's number 2, and this is number 1. This one has a slope of 0. This one has undefined slope. So if it's vertical, it's undefined. Copy that down and know it. Y equals x, you're just going to memorize it's a 45. 45 degrees, so it's going to look like this. See, there's 90, so half of 90 is 45 degrees. So 45 degrees is like that. And then this one, y equals negative x, number 4, is going to be this way. It's just going to be flipped like that. Okay? So you need to know those four right off the top. All right, let's move on. A rigid motion, copy this definition. A rigid motion preserves the size and shape. Now I want you to copy down these rules here, and you need to memorize them. Copy them down just like this. Okay? So a quick way to do this is, if you reflect it over the x-axis, you change the y. If you reflect it over the y, you change the x. Now you might say, well, what do you mean by that? Well, look here. If you take this point right here, over 3 up 2, okay, and you want to reflect it over the y-axis, what you're going to do is count 1, 2, 3 spaces here, and then go 1, 2, 3 spaces here. So if this is the original point right here, let's call it A, then the new point, A prime, will be reflected over that line. It will jump from that to there. And that's what a reflection is. So if you look at this point, which is 3 and up 2, since you're going over the y-axis, you change the x. So change this one. So that would be a negative 3 and up 2. So when you change it, you only change the x. If you go over the x-axis, you would change the y because you're going up and down. Those are the rules right there. See how it says y-axis, you change the x? Now a lot of kids are like, oh no, that's a negative. No, a negative changes it. Like if it's already a negative and you put another negative, it becomes a plus. So the best way to say that is change the x. Okay? And then if you're going over the line y equals x looks like this. So what you do is you switch them. So if this point is over 1 up 4, you would switch them and say over 4 up 1. Over 4 up 1. And when you reflect it, you got to go 90 degrees to whatever line it is. Make sure you go 90 degrees. Don't go sideways. Okay? 90 degrees. Okay? There it is. If you reflect it over the origin, you don't switch them. Okay? This one you switch them. So this one is switch. This one you switch and change. Switch and change. Okay? Again, that doesn't mean negative, it means change it. All right, so what we're going to do, we're going to go over some stuff real quick, and I'm going to get you started. Let's take a look up here. Pay attention now. This one says, which transformations, all right, in a minute I'm going to have you get your workbook out, but not right now. Okay, let's just look at it. Which one is a rigid motion? Well, does this look like that, other than being turned around or something? The answer is yes. So that's a rigid motion. So this one is yes. This one is no because it's bigger. See, it has to save the same size and the same shape. Let's go to number 2. If you reflect it over this line, you're going to go straight to it. So the distance from here to here has to equal that distance right there. This distance from here to here, 90 degrees, has to equal this distance over here. This one has to equal this distance over here. And so the triangle, a reflection is a flip. Okay, so we are flipping it over. All right, now let's take a look here. This one says reflected over the x-axis, so you would change the y. I'm on page 102. So go to page 102. And if you reflect it over the x, you change the y. So this point right here, the x would stay the same. So it would be negative 5, but the y would change to a negative. And that would be called A prime. Okay? This one, the x would stay the same, but you would change that one to a plus. Here, you're reflecting it over the y, so you would change the x. Okay, that's the way you do those. I want you to work 1 through 10 on page 104. So today's work is right here, page 104, 1 through 10. And there it is, and that's the workbook, and it's 3.1. Let's turn our attention now to MCR. Now to do MCR today, we're going to be doing some graphing. So let's take a look up here. And by the way, this is week 6, and this is MCR, okay? So the date goes right here, so it's going to be 9-21, okay? And again, this is MCR class. So if your geometry course, you wouldn't do MCR unless you want to learn something. Let's graph these points. Remember, over is first. So you're going to go -2 and then up 4. That's your first point. This one is over 3 and then down 1, and that's B. And that's how you do it. This one right here, some of you missed this one yesterday or were not sure. You would not subtract this because multiplication comes first. So a negative times a negative is a positive. So that's going to be -3 plus 15, which gives you a positive 12. Make sure you know that. You have to multiply first before you subtract. All right, on a new sheet of paper, copy this down. Let's take a look at this. It says, is it a solution? In order to be a solution, you have to plug in your x and your y, and it has to work. In other words, y is 2, so put a 2 here, and x is 1, so put a 1 there. So it's going to be 1 plus 2 times 2 is 4. Does that equal 5? The answer is yes. 5 does equal 5, so this is called a solution. If it did not, then it would be no. Okay, like if you got 4 is equal to 5, that would not be a solution. This one right here, they want you to use a table, so you just make up any points for x. Usually people use 0, 1, and 2. Okay, so you get to pick those. Now I'm not a big fan of using charts, but that's what they're doing here. So it's going to be 5 minus 0. 5 minus 0 is 5. 5 minus 1 is 4. And 5 minus 2 is 3. So you're going to plot these points here. So you're going to go over 0 up 5, over 1 up 4, over 2 up 3, and your line looks like this. Okay? So that's using a chart. And for this one, you do it the same way. You just make a chart. And you use 0, 1, and 2. Same way. Plug them in. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And then you graph them. Over 0 up 0 is the origin. Over 1 up 3 is here. Over 2 up 6 is somewhere up here. And they all should be on the same line. If they're not on the same line, then you must have done a point wrong. So pick 3 points. All right, this one right here, I'm going to show you how to do the y-intercept, okay? So pay attention to this. It's called slope-intercept form. So the first thing I would do is clear my denominator. You see how that's a 2? I would multiply by 2. It's a little trick to cancel that 2 out. And the reason why you don't do 2 here is because you're multiplying, so this is technically one big piece. So you only do it one time. So it's going to be 2y minus 8 is equal to 1 times x minus 8. Draw a line. Okay? When you distribute the 1, it's not going to change, so that's x minus 8. All right? And now we're going to get y by itself. So we're going to move the negative 8 over here. That becomes a plus 8. And this cancels. And then finally you divide by 2 and you get y equals 1x over 2 plus 0. And the reason why you want 0 is because 0 is your y-intercept. So this is your y-intercept. In other words, where it crosses the y-axis. So it hits the y-axis at 0, and then the slope is the number in front of the x. So the slope is 1/2, so it's rise over run. So go up 1 and then over 2. So up 1 and then over 2, and your graph looks like this. If you're not sure what I did, at this point you can make a chart and use 0, 1, and 2, just like I did before. Okay? So your assignment is right here. If you get stuck, ask. Have a good morning.